So some of the rationale for this webinar comes from what is called a topical expert meeting that is held by IEA Wind. There have been over 100 of them. The 109th TEM was focused on the grand challenges of wind energy science. And the idea here was to bring in different scientific areas and facilitate collaboration among these areas. Oftentimes we kind of work in our own silos, but to address the challenges of wind energy going forward and to try to meet renewable energy goals, it's important that we collaborate across research fields. And IEA Wind is organized into these 5 scientific areas, and Task 59 and Task 60 fall within the environmental co-design scientific area for IEA Wind. So it just makes sense for us to kind of get together and understand what areas we're working on that overlap and how we can assist each other going forward. And so today's webinar, we've got several speakers. We'll start off with brief introductions for both tasks, and then get into an introduction into life cycle assessment and why we do LCAs, followed by an overview of the environmental impacts of wind energy and the data that are collected. Then we'll move into how we can incorporate biodiversity into LCAs. What models do we have, and what do the results show? We'll end with a presentation on takeaway messages, and then with time remaining, we'll have time for Q&A for participants to ask our panelists. So again, if you do have questions, please enter those into the chat, and we'll get to those after all of the presentations are done. So with that, I'll stop sharing and hand it over to Laura.
Perfect. Hey guys, I'm Laura Dempsey. I'm a researcher from the National Laboratory of the Rockies in the United States. I'm going to give a really brief rundown of Task 59, which is WREN, so the Wind Energy Environmental Research and Engagement Network. And so if you're familiar with the name WREN, but by a different kind of number or acronym, we're the same as formerly Task 34. It began our new iteration of WREN in October of 2024, and we're currently in phase 1, and we have 12 member countries. Really kind of the primary motivation of WREN stems a lot from the topical expert meeting that Cris was mentioning, kind of encouraging how do we kind of collaborate to overcome the grand challenges of wind energy. And kind of some of the main activities of WREN. The first is to update content on the TETHIS website. And TETHIS is a knowledge hub that aims to advance wind energy research by improving access to environmental information through aggregation and dissemination of high quality science. And I'll put the link to that website in the chat after my presentation. The second is to encourage collaboration among disciplines. Where it's so often we get stuck in our esoteric silos of what we study and trying to, encourage people to talk across those. The third is engagement and outreach. And finally, to facilitate broader international collaboration, particularly from geographical areas or countries that have been less often kind of represented in this type of work and research. Just a brief, non-exhaustive list of the kind of topics that WREN covers, looking at risk-based management, cumulative effects, mitigation hierarchy. So we definitely kind of run the gamut of topics we're looking at in terms of environmental effects of wind energy. A couple of quick accomplishments to date, and all of these can be found on that TETHIS website, so I encourage you to check that out, and I'll just highlight 2 in a little bit more detail. So WREN helps run a wind energy monitoring and mitigation tool, so we catalog different technologies associated with monitoring or mitigating environmental effects of wind energy. And we currently have 110 technologies, and we're always adding more, so I encourage you to check that out, or submit a technology if you know of one that's not currently listed on the tool. And then finally, a tool that is looking at environmental monitoring metadata, and we currently have 41 projects from 8 countries. So just a quick introduction to WREN, so thank you guys all so much, and I will pass it over to Cristina.
Hi everyone. First, thanks for joining us today. My name is Cristina-Maria. I am a researcher at Sintef Ocean in Trondheim, Norway. and today I will briefly introduce IEA Wind TCP task number 60, CYCLEWIND, which I co-chair together with my colleague also present here, Matthias Stucki from Zurich University of Applied Sciences in Switzerland. Let's see. Yes, the aim of CYCLEWIND is to harmonize and improve LCA of wind power to increase the comparability of such studies and to support long-term sustainable decisions. The initial steps towards setting up CYCLEWIND were in autumn 2023, when Matthias and his colleagues hosted us, around 30 participants from different research institutes, universities, wind power developers, original equipment manufacturers, and industry associations from over 11 countries. The discussions during that topical meeting were focused on the need for more comparability of LCA studies in the context of wind energy, the need for increased consistency, as well as transparency in such assessments. It also pointed the lack of standardized reference cases, which are available for other renewable energy systems. And of course, as always, when it comes to LCA, the big elephant in the room was the data topic, the limited availability, as well as the outdated status of the databases used in inventories for LCA. Once the need for such a task was evident, together with Matthias and with help from our members, we have planned this mandate of 4 years for CYCLEWIND. We are organized in 5 work packages led by different institutions. So we have work package 1 dedicated to development of LCA methodology guidelines, work package 2, which is focused on gathering reference inventories for both onshore and offshore wind power system. Work package 3 is the one where we aim to zoom in into different case studies, again for onshore and offshore. And work package 4, which is where we concentrate our efforts towards dissemination as well as collaboration with other IEA tasks. Now, if we take a closer look at specific activities we are carrying out in work package 1, this year we are aiming to finalize the first version of the methodology guidelines. We plan to finalize the system boundary report by next month, and the impact assessment and end-of-life reports are also currently in progress. We have also started a broader effort in establishing lifecycle reference inventories for both onshore and offshore wind system, and these we plan to make them available in the second half of 2028. In connection with the activities that we are carrying now in work package 1 and the different discussions we've been having there, we already started laying out topics for case studies that will be carried out as part of work package 3 starting mid-next year. And finally, work package 4. Here, we are aiming this year to finalize a recommendation for LCA inclusion in wind energy auctions. And other activities are dedicated to publishing fact sheets regarding different aspects of wind power LCAs, as well as establishing connections and fostering collaboration with IEA tasks, such as the ones dedicated to grid integration, hydrogen, as well as within our own wind TCP, such as the joint action today with WREN and this webinar. In addition, we're aiming to provide a platform for collecting and sharing primary data in the supply chain of wind power, in order to facilitate information exchange and increase the transparency and comparability between LCA of wind power. Before I finish, I would like to briefly present our members. We have 9 countries, and you see the corresponding national flags now on the screen, and 1 industry association, Wind Europe, which is also part of CYCLEWIND. We are currently more than 20 institutions in this consortium, and me and Matthias, we are at the moment involved in discussion with a couple of other institutions and countries interested in joining us. Yes, thank you very much for your attention, and feel free to take contact with us should you have any questions.
Good, then I will take over. Hello and good afternoon, everybody. My name is Matthias Stucki. I guess you can see my screen now. Can someone confirm?
Yes,
perfect.
Lovely.
So my name is Matthias Stucki, and I'm co-leading CYCLEWIND together with Cristina. And I have the honor to give you a very short introduction into what is life cycle assessment and why do we find it important. And I would like to start a little personal. Myself, I am now 42 years old. So when I was born, the concentration of CO2 in the atmosphere was 344 parts per million. And then just a few years later was the first time when the planetary boundary was exceeded a historical level on CO2. And ever since then, it was just going up, up, and up, increasing. And when I checked this morning, the latest number is that today the concentration of CO2 is 431 parts per million, so significantly higher, leading to global warming. And also for me, being a parent, that's one major concern. And also a very big motivation for doing LCA, since I believe that LCA is very strong in giving us guidance and helping us for decision support for making decisions that leads to a more sustainable future. So what is this life cycle assessment? When we look it up into the standards of the International Standards Organization in ISO 40040, we can read that LCA is defined as the compilation and the evaluation of inputs and outputs and the potential environmental impacts of a product system throughout its life cycle. And especially this life cycle perspective is absolutely key in LCA, and it is relevant when we assess different product systems, such as, for example, wind energy, wind power as a technology. And every other product system, it usually starts with natural resources being used, for example, in mining. Then we have a production step, we have processing, manufacturing. There are often various transportation involved. Then many products also have a use phase where there can also happen environmental relevant impacts. And then we come to an end of life where we have recycling or waste treatment. And in every one of these steps, there is often the case that resources are being used, energy is used, emissions can occur. So what LCA does, it analyzes the mass and energy flows in all these different steps, and it quantifies. So LCA is a quantitative method that quantifies these impacts, and it covers impacts on human health, but also impacts to the environment, of course. And ultimately, the goal is to help decision makers to understand the size and the sources of environmental impacts along the life cycle, for example, of a product system. So why is this life cycle perspective so important? Now, with the global economy being so strongly interconnected, every decision we take in every country often also has strong effects in other countries, especially in industrial countries. When we take a consumption perspective, relevant emissions are caused in other countries for the goods that are produced for our consumption, and this leads to these, for example, to these virtual CO2 emissions, as you can see here, for example, by products being produced in China and then consumed in the US or in Europe. Also, when we look at my home country, I live in Switzerland, we can see here the development of the overall total environmental impacts per capita over the years. And what you can see is that we quite successfully managed to decrease the environmental impacts, the domestic environmental impacts inside our country. But when we include also emissions that we are causing abroad through our consumption, this is one part which is very hard so far to decrease. And this is also why the supply chains often dominate the environmental footprint of industrialized countries. When we also look at what we can see in the ISO standards is that every LCA should have these 4 steps covered. The very first one being goal and scope definition. Then the second step in every LCA is the life cycle inventory analysis. This is the step where we gather all the data that we require to do an LCA, where we put the data together in one large model, typically in an LCA software, where we model the whole product system. And then based on that model, we come to the third step, which is the lifecycle impact assessment, where we, based on the lifecycle inventory model, we convert the results into different impact indicators, so typically environmental or human health indicators. And then these results are finalized with an interpretation phase, where we also give guidance and recommendation and decision support based on these LCA results. Typically, LCA is being used for product development, but also in environmental planning, for eco-design, but also for political decisions, for marketing. So quite a wide range for different decisions. Within CYCLEWIND, as Cristina mentioned, we are now working on harmonizing LCA methodology in the context of wind energy. And in the goal and scope phase of every LCA, you typically would define the product system to be analyzed. And we are also trying to harmonize that. And on that image, you can see that every wind power LCA should include the raw materials, fuels, energy, transportation being included. Then coming from background system and into our foreground system, where we have a pre-construction phase, raw material supply and component manufacturing, transportation and installation steps, operation as well, and maintenance of the wind power plant, and decommissioning and end of life. Our LCA model then typically covers a large range of numbers and information, and we also conducted the first inventory of different wind turbines in European context. And also, we published this for different LCA databases to be used in the background database, and we compared offshore and onshore wind power in Europe. And when we jump here to the LCA results, you can see here the greenhouse gas emissions, life cycle greenhouse gas emissions for per kilowatt hour of electricity. You can see that it's in the range of between 10 and 25 grams of CO2 equivalent per kilowatt hour. And the carbon footprint of these wind turbines is typically dominated by the materials involved in the moving parts, in the tower and the foundation. And also, we can see that there's a tendency for higher impacts for offshore wind power, and that's also because there's of all the vessels that are involved for installing and transporting the different materials for the offshore installations of wind energy. With that number being said, when we look at it in a larger context and also compare it to other power generation technologies, you can see here from hydro up to the European ENSO electricity mix, you can see that wind power with an average in carbon footprint of about 14 grams CO2 equivalent in Europe. This is 19 times lower than the grid electricity mix, ENSO electricity mix. So this makes wind power as a renewable energy a very low carbon intensive energy, together, for example, with hydropower. So we talked a lot now about carbon impact and climate change. Of course, it's important that in LCA we cover not just carbon impacts, also other environmental impacts such as ecotoxicity, air pollution, water contamination, resource depletion, and also biodiversity loss. Maybe you have seen this graph before, that after COVID and there is some economic crisis, the climate wave now, the biggest wave could be the biodiversity collapse. And that's also one reason why there is such a strong need also to include biodiversity assessment whenever we do any sort of LCA. And the latest IPBES report that was published this year also emphasized the very strong dependence of business on biodiversity globally. When we look at what the European Commission does, where LCA is quite strongly pushed and a lot of policies now require also LCA and LCA results, we can see that the European Commission published the harmonized environmental footprint methodology, which is an LCA methodology covering these 16 different environmental indicators, and is now getting more and more used also in the LCA world. And what I also found quite interesting is that when you look at these indicators, biodiversity is not yet included as an indicator. But of course, many of these other issues that I mentioned here, such as toxicity or eutrophication, they have a very strong effect on biodiversity. So like this, it's already partially included, but it's not as such an indicator itself yet in the EF methodology. From changing the perspective from the policy side, also in the economic side, in the business side, is also LCA is gaining more and more attention. And one way often companies present and publish their LCA results is through EPDs. EPDs are harmonized environmental product declaration. And one example on wind energy you see here from Vattenfall, for example, who published an EPD of electricity from their wind farms. And you can see it contains a lot of numbers and for all the different indicators that they have assessed in their EPD study. So that's what is LCA all about, and I hope I could give you some hints why I find it so important. Within CYCLEWIND, we are now working on modeling more differentiating installations of onshore and offshore wind energy, also the vessel activities involved. And also we would like to more emphasize additional indicators, especially biodiversity, because so far LCA is facing some challenges, also how we can quantify biodiversity in wind power LCA. And with this, I thank you for your attention, and I would like to hand over to Roel.
Good. So, Matthias already kind of started to go into it. We have LCA, a powerful tool used in many different ways, but one thing is mainly lacking, that is still biodiversity, or also what is called the ecosystem quality. So, diving a bit more into that. Because we not only talking about climate change here with regard to wind energy, we actually have a triple planetary crisis that we have to deal with. And that also means that we actually need to not only consider climate change and reducing carbon emissions, but also looking into biodiversity loss and land degradation. And why is that? Well, I think it is important that we also kind of need to step a bit back from what is often being said in the media, kind of, we need to battle the climate crisis, but also to broaden the narrative a bit, not only to have a habitable climate, but also sustainable biodiversity and also the services that we as humans gain from nature. And so with that, you see that already kind of, okay, we have this wind power, which is to mitigate climate change, which then also might have negative impacts for biodiversity. So back to LCA. You have these different areas of protection, as they are called, which are kind of ecosystem quality, natural resources, and human health. Focus a bit more on the first two. And as Matthias also showed, kind of you have these various impact categories that are often being considered in LCA, and one of them being land use. And I said kind of biodiversity in itself is not there yet, but of course land use is of course a very central one, because if you use, let's say, 100 square kilometers of land, that's fine, but what does that mean? What are actually losing? And I think that is kind of where you also move to two different types of impacts in LCA, either the midpoint, which is like you lose 100 square kilometers of land, to what am I actually losing here? What is actually the impact? I mean, it's habitat for species. Is that loss? Are species disturbed? Are they getting killed because of the presence of turbines? So knowing the impact pathways that are actually occurring on that land will allow you to actually assess biodiversity loss. So what is happening to the receptors, to the species, as a kind of endpoint impact. And is land important to consider? Well, here are some numbers just to show you, just to give the point kind of that if you look at these different types of energy sources, then for example, on the top level, you have hydropower, which takes up quite a lot of land, but below at the bottom and also on the side, you can see that, well, the direct impact of wind turbines, that's quite minimal. That's not a lot. But of course, you're not building one wind turbine, you're actually building a wind farm, which means that you have a much larger project area and influence area. And that is actually quite large. So the area where you potentially have an impact on biodiversity. And as the numbers show, that can be quite large areas if you would put all the turbines on the globe together in one area. So what are the impacts then? Here are two kind of pictures to visualize that, both for onshore wind and offshore wind. And as you can see, kind of it ranges from everything that some species are affected by fatality through collisions, but also kind of, loss of habitat and disturbance of their behavior, both directly or indirectly. And these kind of aspects happen kind of on the land. So that is the values that the species have of a certain area and what they lose, because either they are kind of lose their direct habitat or actually are disturbed from it. So that is important to know kind of what is happening when you build a turbine in a specific area. The same you could also say for socio-ecological effect. So the ecosystem services, the contributions that nature and the benefits that we gain from nature as humans. Those may also be affected. We might kind of, if there's a wind farm being built, you might actually lose access to recreational sites. You might not be able to do berry picking or hunting or fishing, etc. These kind of things can also be affected. That is also important to understand kind of what the impact is on that. So then, of course, we know what the problem is. We have land take. We know there's ecological effects. How do we deal with that? How do we actually model that? As Matthias mentioned, also one of the first steps is to do an inventory of data. Kind of, okay, where is the problem? What do we have? What do we know? For biodiversity, that may also be somewhat different than from a standard LCA in a sense that it's very much spatially explicit. It matters a lot where you have a wind farm of how much impact you will have. That is this map showing here. You can assume that kind of, you probably know that the biodiversity hotspots in the world are around the equator. So building something in the equator will have obviously a much larger impact on biodiversity than in other biodiversity less important sites, but also locally, like for example this example in Norway, it matters where you build things. So that is, it is very much space explicit that we have to take into account. On the other hand, species move a lot of time, so it's also, you often have to consider a large extent to be able to really model it fine in a fine way. So what data are we using? Often we're using citizen science-based data, because that is the most available and has the highest coverage in most cases. So here are some examples of that, just to show that. But of course, we don't have observations throughout the globe on every given site. So it's often also combined with predictive modeling, either using species distribution models or using even remote sensing proxies to kind of measure it and trying to quantify it everywhere we want, so we can actually quantify the impact. Just to give you an example of kind of what we're talking about when looking at different data sets, but also looking at kind of the scale of the data we're looking at. Just look at the pictures of whale migration and bird migration. That's happening across the globe. You know, that's happening. So that means that if you're affecting an individual whale somewhere, it might also be affected somewhere else entirely. Whereas other species might be more localized, like porpoises or coral reefs, that may be, you know, very much more static. But also the lower pictures on the for seabirds, you can see that the two left ones are data from one colony at Cristina in Norway. And actually, as you can see, kind of depending on which season we're talking about, they're not just around hanging around in Norway. They're actually losing quite large areas, you know, losing the North Sea, even going down to Greenland, etc., and back again. So you don't even know which bird you're actually affecting. You know, in a Dutch wind farm, for example, you might be affecting Norwegian birds and vice versa. Other species might, of course, be much more local, as the European shag in the corner. So why is this important to include this better? And I think the main points that I would raise here is to say that it's first about internalizing externalities. In many ways, so far in development of wind energy, social and ecological aspects have been seen as something external to development. So you first optimize your wind farm development based on economic output and production. And then you have to take into account these other aspects, which is only kind of to hamper your development and is kind of just kind of an extra cost to that. So making it part of the entire project, because you cannot say it's optimized if it's not taking into account social and ecological aspects. And that is also shown in this colorful graph on the top, where we did an analysis of where wind farms in Norway were located. When you look at it from the y-axis, the levelized cost of energy, you can see that, well, they did a quite good job in finding cheap sites. So good sites for production. But if you look at the x-axis, the PDF, which is a potentially dissipate fraction of species of birds, you can see it's all over the place. They didn't really consider that in a very strong manner. But secondly, I think is also an important point, and already also mentioned by Matthias, is overcoming these disciplinary silos to start think across different disciplines. Because I think that what is an important point here is that engineers and kind of you could say the standard LCA community is very much thinking about the life cycle of a product. So you start with mining, you transport everything, you construct or manufacture and construct a turbine, and that is the impact you're talking about, and that is what you're trying to minimize. From an ecological point of view or an environmental impact assessment point of view, you'd be looking at construction only. You'd be looking at turbines. Okay, and what are they affecting? Different species, different parts of the ecosystem, etc. And that is what we're trying to, well, we want to try and minimize the impact. So we're looking at it in two different ways, and both are important, but it's good to be aware of that. So starting to go into kind of the environmental impact assessment, so the ecological focus in a way versus LCA. I think LCA could be a very important tool for that. Why? Because I think that in many ways, LCA practice is often faltering. You know, the concept is okay, but often it lacks consistency and quality because dependent on what data is being used and how interpretations and evaluations are done, which is in a semi-quantitative, qualitative manner. And also because it often lacks alternatives because it's hard to do. So you often compare a zero alternative of not constructing something with the proposed construction, but not having other alternative sites for development. And LCA, I think, is a quantitative measure where you can actually have a strong role also in the early planning phase. So actually have a standardized approach to quantify the impacts, be very transparent of what is actually being assessed, both in the impact pathways and what receptors are done, which can also be directly compared among different aspects, which I think is very important. Just a very quick, some images of how to look at that. We did this work also for a strategic environmental assessment. So you can see for seabird richness and for migratory birds, you can actually kind of map it over large areas, compare different sites, and also look at various impact pathways in the same way. And then kind of you can, after that, also zoom in for a project-specific environmental impact assessment. Same for ecosystem services, where you can look at kind of what are the impacts on various ecosystem services within a given proposed area. But at the same time, you can also map it at a larger region and say, no, okay, but was it actually, could we have done a better job in siting this wind farm or not? Are there better sites we could have considered? So in the end, I think it is very important that it's all down to making the right decisions. I mean, LCA is just a tool. It's not giving us answers. It's giving us insight in kind of where possible problems could occur, and also inclusion then of ecosystem quality would give us an extra handle on that. But in the end, decision makers will have to make decisions on kind of balancing ecological and economic benefits. And that also means that we have to be very wary of kind of that we use the best available knowledge and set thresholds on kind of doing good balances. And then we have to be very wary and also kind of know of these different types of uncertainty. And maybe most focus so far has been put on kind of natural or environmental stochasticity or variation. Statistical, maybe limitations of what we actually can prove or not. But the other ones are just as important, and those are very hard to actually do something with. But being transparent of what we're doing here with LCA and what we can show will hopefully also help overcome these other types of social doubt or planning irrationality, etc., etc. So with that, I would like to thank you and then hand it over to Dafna to dive more into how we actually can do this.
So yes, so I will actually discuss how wind power impacts on biodiversity are actually assessed in LCA. And first I'll just start with the concept of biodiversity, first to just ensure we are all on the same page. So biodiversity is the variety and variability of life at three interconnected dimensions. So we have genetic diversity, species diversity, and ecosystem diversity. Why do I mention it? Because LCA does not cover these three dimensions equally, and it's important to acknowledge it. So there's a large share of biodiversity LCA models that focus on species richness. So they assess how stressors can lead to a reduction in species richness. And ecosystem diversity is only partially and indirectly represented in LCA. So we can assess biodiversity impacts within three types of ecosystem, terrestrial, aquatic, and marine. But ecosystem functionality, for example, this is often overlooked in LCA. And then finally, genetic diversity is rarely quantified in LCA. So there has been a lot of progress, and lots of models were developed to integrate biodiversity into LCA, but we still don't really have this one method that can capture all of the impacts on biodiversity and ecosystems. So as was mentioned before by Matthias and Roel, there are biodiversity impacts can be quantified in LCA by using generic impact pathways like land occupation or ecotoxicity. So these impacts are then linked directly to lifecycle inventory and can be used by LCA software. But then in recent years, new biodiversity LCA models were developed, which quantify biodiversity impacts that are specifically associated with wind power. So if we look at this figure, for instance, this represents the key impacts of onshore wind on biodiversity. So you can see the little numbers which indicate different impacts. And there were models that were recently developed to quantify impacts of collision of species with wind turbines or power lines, habitat loss, electrocution by power lines, barrier effects, and also ecosystem effects. And then in addition, there are also some impacts that can that you can quantify in LCA. So for example, pollution, but again, this is quite a generic one. And there are also models that where you can quantify the impacts of the introduction of invasive species. But again, these two, they are not specifically made for wind power. So they need an additional adjustment if you actually want to use them. And then, of course, there is still lack of models. So there's still some impact pathways that there are no models, so we cannot quantify it yet in LCA. So there are different types of models that you can use in LCA to quantify impacts on biodiversity. And often what is used is the species accumulation curve. So for example, the species area relationship, which quantify impacts by translating reduction in the area size to potential reduction in species richness. Another example is the species sensitivity distribution. So this explores which species are most sensitive to the exposure of a certain stressor or substance. And then some models also use species richness models, where you basically use a state of species richness. So what was it before a certain phase, or for example, construction, and what happens afterwards, and then you compare the different states. And these models use different impact indicators. So the most common one would be the potentially disappeared fraction of species, the PDF, which quantifies the potential loss of species richness due to a certain stressor, for instance, habitat loss. And then the PDF can be expressed per functional unit. So models can calculate impact per unit of electricity produced, so PDF per gigawatt hour. But it can also be expressed per unit of pressure. So for example, PDF per kilogram of plastic pollution. Then there's also the potentially affected fraction of species, the PAF, which estimates the share of species that are affected by a certain stressor. And this can also be linked to functional units. So for example, the PAF per pH change. There are, of course, different types. So there are more indicators that you can use to assess biodiversity in LCA. But if we talk about wind power, then these two are really the main ones, especially the PDF. So across the biodiversity LCA models, birds are the most represented taxonomic groups to assess impacts associated with wind power. The next most represented group, there are mammals, and there are different models. So some models will focus on terrestrial mammals, some on marine, and some on flying mammals. And for offshore wind models, most of them focus on impacts on benthic communities. And then there are a few models that also evaluate impacts on amphibians and reptiles. Looking at the geographical coverage, so in LCA, biodiversity impacts can be modeled at regional or global scales. But most of the biodiversity LCA models for wind power are modeled at the regional scale, mostly focused on Europe. And there are different reasons for that. So first can be limited availability of global data. So that can restrict models to then specific areas. Another reason is if you have models that if you intentionally want to look at a specific region. So for example, if you want to look at potential impacts of offshore wind development in the North Sea. And then another reason would be if you want, because local models will often have they'll be a bit more accurate than global ones because they will use finer spatial resolution. So you can have, for instance, a global model, but then you can also zoom in. And then in that case, you will have you can focus on a certain country, for instance. So the biodiversity LCA models, they depend on 3 different things. So you need to have spatial data, as Roel mentioned. In some cases, you need to have species-specific data. And then you also need technical data regarding the wind farms. And then these models are often implemented in programming languages. So for example, Python or R. So to get results, you need first access to the data, and then you also need to run a code. And you get various results from these models. So one result can be comparison of impacts across different projects. So this is an example for Norway, where on the left you can see a list of different onshore wind projects and their impact on biodiversity, and then on the right you can see them on the map. You can also look at impacts across different species groups. So in this example, across bird orders. So you can see which impact pathways affect which bird order the most, and then you can also have overall see which groups are then more affected by wind farms. You can also aggregate the results to countries and then compare impacts across different countries. And in that case, you can compare between current projects, and then you can also model impacts for potential projects if you know approximately where the project is going to be, and then also how much electricity each country is expecting to produce. So to sum it up, we can quantify biodiversity impacts, but these are mostly addressed indirectly through generic impact pathways. And there has been a great development in biodiversity LCA models associated with wind power, but they are not yet implemented in standard LCA software, and they require external application. And of course, these models depend on data that is not available yet in conventional LCA inventories. And because of that, direct, localized, and species-specific impacts of wind powers are still mostly overlooked in LCA today. So there's more work that needs to be done.
Thanks to Roel, Dafna, and Matthias for the presentations today. And thanks for the 50+ participants that are still online with us. I will try now to very briefly summarize the content presented by them in 5 simple takeaway messages for you now. Okay. So, as Roel showed us, it is important to include biodiversity and wider ecosystem impacts in LCA in order to account for the damages from the deployment of wind projects, and also to facilitate optimization across multiple objectives. Dafna introduced us to the topic of how biodiversity impacts are quantified currently in LCA, and she highlighted that currently the impact pathways considered are mostly generic ones. Nevertheless, she pointed to different new models and characterization factors which are made available by different research teams across the world, but these are not yet available in standard LCA softwares. And these standard LCA softwares, which are the one that usually LCA practitioners are using. This means applying novel approaches, even when they are available in the scientific literature, they require additional work outside the traditional LCA softwares. Even so, there are still impact pathways which are not yet got in the life cycle impact assessment methodologies available currently. And now lastly, I would like to highlight that joint efforts across different disciplines are difficult, as they might be difficult they might be as to organize, are probably the key to move forward in the direction of improved models of biodiversity impacts from wind power systems in life cycle assessment frameworks. And this idea was highlighted quite nicely by both Matthias and Roel there. Yes, I think that's what I kind of wanted to summarize here.
Thank you to our speakers, Laura, Cristina, Roel, Matthias, and Dafna. Really appreciate those overviews. We have about 10 minutes for Q&A. And so if you do have questions, please put them in the chat. We have several already, so I'm just going to start at the top. Matthias, I think these are for you. But please, if anybody else any other panelists have thoughts, please weigh in as well. So the first question related to the EPD, do you know why biodiversity is not yet an indicator up until now? Is this based on the LCA traditional way of looking at impacts? Yeah, that's the question.
Thanks for the question. Maybe I can start with answering that question. Maybe others have also input. I guess there are several reasons why it's currently not so much used, and I hope we also answered that partly in some of the presentation, and especially also in the last point from Dafna, where she showed that if we want to integrate LCA, we need more direct, localized, and species-specific data and impacts, which is often also not available and which is challenging to get, which I believe is probably one of the reasons why it's not done so often. And then also it's not implemented in standard LCA software. It is probably another reason. And then maybe one additional point is that there is some overlap between biodiversity and the classical midpoint indicators in LCA, such as climate change or land use, which are also affecting biodiversity. And often this LCA focuses much more on this midpoint level than on the endpoint level, where we have the area of protection of ecosystem quality, especially in the EPD context.
Can I add something here, Matthias?
Yes, please.
I would say that the main reason why EPDs are overlooking biodiversity impacts is basically because the standards that are actually required in order to produce an EPD, they do not have biodiversity as one of the indicators required. Climate change impacts, so CO2 equivalence is one of them. There are a couple of others, but fair and square, these standards do not highlight at the moment biodiversity indicators as important to have there. That doesn't mean they should not be included, but the strong recommendation is for the other indicators to have them in the EPDs. I hope this answered the question.
That's a very good point.
Maybe to add one thing to that, and I think which is also that a lot of practitioners may not be aware of ecological impacts. I've had several conversations also with people and actually saying that kind of, okay, you're doing a full LCA. What does that mean? And then they're showing kind of the standard impact categories that are often done. And I'm saying, yes, but what about, ecosystems and species? And then they kind of start wondering, kind of raise their eyes and saying that kind of, is that a problem as well? It is also very much about kind of overcoming these silos and, communicating basically. And of course, now models are being developed for biodiversity, but I think it also just takes time to reach these people and to make them aware of that and that it can be done. So I think we need to go both ways, because of course, if it's still hard to do, it will still not be done, even if they are aware of it. But they also need to be made aware of it, that kind of it's an effort on both sides, I guess, to make it more available and to make them more aware of it so they actually can do it.
Okay, great. Our next question, how do we calculate carbon emissions from building wind farms? Did the extra emissions from things like cutting down forests for different land uses be counted, or were they counted?
So for calculating the overall carbon emission or life cycle and greenhouse gas emissions of a wind farm, we do quantify at every stage in the life cycle all the emissions generating different greenhouse gas emissions, not just CO2. And then we convert them into CO2 equivalent typically. And if there would be deforestation for an onshore wind power farm, then yes, then we would have to include that aspect as well. But basically for most other cases where you don't have deforestation, typically what we would be dominating for the carbon emissions are much more carbon emissions related to the manufacturing of all the materials and in the offshore context also for operating the vessels.
Okay, thanks, Matthias. So beyond the research context, where do you see the most realistic application for LCAs? Is it primarily a tool for strategic or government level energy planning at the landscape scale, or for comparing wind with alternatives like solar or hydropower? There's more to this question, but maybe I'll just pause there and see if anyone has a response.
I could start maybe. Well, I'd say that it has great value in at the early planning stage and also for policy development. So the early stage kind of making decisions on first, do we want wind or do we want solar? Which is more of a, you could say, more of a political question in the first instance. But secondly, also kind of once you have made a decision on that, you want to look at one type of renewable energy source. Where can we actually do it? So from a strategic environmental assessment, kind of where are potentially suitable sites to actually open up for the option of development? And then within that, kind of for environmental assessment. So it's kind of a funnel in a way, kind of to get more concrete in a way. But it's especially at the planning phase. And as also Matthias also mentioned, and of course, at the end, once you have developed some things and you have done several activities, then of course you need to report on that, like corporate reporting, sustainability reporting. So that is then another aspect that where it also has value to actually make that much more clear on kind of quantify kind of actually what you're if you are sustainable and to which extent you are that.
Maybe I can also comment on that. I totally agree with everything you said, Roel. And typically we experience that there is like some sort of trade-off, that the earlier in the planning stage we do an LCA, the bigger we can still influence the decisions, for example, on location. But of course, we have a lot of uncertainty and we don't have a lot of data to model the LCA. And the later the stage is, the more we have data and we have a high qualitative result, but we cannot influence the decision anymore. So typically we try to do an LCA as earliest as possible and then come back and redo it again and improve the quality over time, because there is several decisions along the way.
Great, thank you. Next question. This one was for Dafna. Do we have any available databases to look for biodiversity impacts of different sectors or products?
I mean, the question is from myself, if everybody can hear me, so I can also jump in a bit to give a small context of my question. So for instance, we have been doing LCAs, let's say, maybe most of us are doing LCA with a standard database called EcoInvent, where once in a while we can look into the database, go into the background information and sneak how the data is collected, from which year is it, or a bit of basic information, just to get a bit more insight about the data set. Similarly, do we have something like this for biodiversity? So in case if we are looking for something in the wind farm, maybe if we want to look into how, let's say, a bit of a sneak details about any particular species or particular sector or something like this, is it already available is it already something that is standardized?
I think maybe Cristina is more familiar with that, but I think in like normal LCA software, you don't really have it. I think if you use Brightway, then this is actually an application where you can actually get, I don't know if you get it access, but you can definitely load it and use it.
Okay. And then you can, then I also had the opportunity to like see the background processes a bit, or like the background information about the data set.
I think so, yes.
Okay. I mean, I'm not sure. I'm just asking. I have absolutely no idea.
No, but also to get in a bit. I mean, I think so far, at least what we've been developing at NINA is also very much that we start from scratch in a way, kind of collecting like citizen science data that I mentioned from official open repositories, and using that to build predictive species distribution models, which are then the input and the starting point of kind of starting with the LCA. So, I mean, those are available kind of when we publish it, but of course not publicly available as part of an LCA database. And that is kind of also the difficult part in a way, because even if we would share it, it would also be kind of a small case. It would be maybe a map for Norway, which is quickly outdated as well. So that's kind of the downside. And I think there we still have a long way to go. But one way, that means things are happening in a way. I know, for example, for Norway, they're building also a platform that you actually can automatically build species distribution models dynamically. So every time you build it, it's being kind of automatically updated with the newest data. If that is available, of course, then every time you could run a model, you have an updated version of what is happening. Now, of course, that's only Norway. You would actually have to have it for Europe, the globe, etc. So that's, of course, that kind of still far into the future. But once those kind of things are more available, then, of course, you can much more and much better kind of build, make those biodiversity models accessible for the LCA community.
Thanks, Roel. Thanks, Dafna. Thanks, Cristina.
Well, we're just past the top of the hour, and so apologies, we were unable to get to everybody's questions. Thank you so much for attending today's webinar. We appreciate your participation, and we plan on a couple of workshops to help address this gap, and we'll report out on the findings of those workshops once all the work is done. So again, thanks for joining today. We appreciate your time, and look forward to continuing this conversation.